So we're factoring radicals with variables that are involved. So you already know how to factor them out if it's just the number format. But now if we throw in some variables, you have to understand how to factor that as well. So if we have an expression that is the square root of x to the fourth and y to the third. X to the fourth, y to the third. Okay? When you've got them underneath the radical sign, the thing that's important is that the square root, anytime you take the square root of an even numbered powered exponent. So anytime your variable has an exponent, that's a power of an even numbered value. It's the same thing as just dividing the exponent in half. Okay, all you're having to do is divide that exponent by 2. Now, if the exponent is odd and it's greater or equal to 3, so obviously it can't be a 1, but if your exponent is 3 or 5 or 7 and so on and so forth in those odd number forms, then all you would have to do is remove one variable of power of 1 to get the exponent to become even. Okay? So all you have to do, so for example here, we've got an even exponent. X to the fourth is even. We're good. All we have to do is divide it by 2 and remove it out of the radical. But y to the third's odd. So what I'm going to do is I'm going to take one of the y's out. So I'm going to separate the y to the third. I'm going to separate it into 2 values, y to the second and y to the first. Because y to the second times y to the first is y to the third. So if I remove a y to the first, I now have an even-powered exponent that I can simplify, and that y to the first stays inside. Okay? So let me just show you again. In the pink, I've got my even-powered exponent. So I'm going to focus on this. I'm going to separate it out as my radical x to the fourth. When I simplify it, it's going to simplify to x to the second, and I no longer have the radical sign. So the square root of an even-powered exponent is just remove the square root, divide the exponent in half. Is everybody clear with that so far? Okay. When it is an odd exponent, so y to the third has an odd exponent. What I'm going to do is I'm going to remove one of the variables and put it as a power of 1. So I'm going to remove one of those y's and put it off to the side because it now has a power of 1. It's just square root of y. If I remove one of them, what am I left with? Y to the second. So now I have y to the second. And now all I have to do with that y to the second is follow my even powered rule. What do I do with an even power? Split it in half. So instead of y to the second, it now becomes y to the first, or just y. And then the square root of y stays inside. So your final answer is going to be x to the second y square root of y. Do you guys understand now why I really think that there's an importance of having these colors? Yes. It helps you to see when you have to split things up. Okay? Well, when there's, we'll work it out when there's actual numbers and variables involved too. Yeah. We'll combine that process today. Okay. Shh. So let's take another look at one that's just variable format. So if I've got x to the 5th, y to the 8th. X to the 5th, y to the 8th. So the first thing I need to do is I need to identify, I'm going to split them both up into their own components, square root of x to the 5th, square root of y to the 8th, but I need to identify whether they are an even or an odd exponent so that I know where to go from there. So let's start with x to the 5th, even or odd? Odd. Odd. So I'm going to go ahead, I'm going to highlight that in my green because that's where I'm working with all my odds. And I know that this is going to be split up as square root of x to the 5th. Now, I need to do what? Once I've identified that it's odd, how do I work from there? What do I need to do? Colin? Okay, so I'm going to have two square roots now, right? Square root of what? X to the 4th. And then a square root of just x. I'm going to zoom in so you guys can see it a little easier. So that's all I've done so far. X to the 5th is odd, so I have to break it apart as x to the 4th, which is just 1 less than 5, and then x, because I've removed that 1 away. So now I've got an even and a single. What do I do with that even?
You split it in half and turn it x to the second?
I split it in half, turn it to x to the second. Do I put the radical sign?
No.
No. Because once I've split it in half, it means I have performed that radical signs operation. So this now becomes x to the second, but I still have that square root of x. I still have that square root of x. Okay? So this is as simplified as the x is going to become now. Now let's work with the y. Y to the 8th, is that even or odd? Even. Okay, so we've got our even power. So we have square root of y to the 8th. And if it's an even power, what do we do? Divide it by 2, split it in half. So what is that going to become? Y to the 4th power. Do I have a radical sign? No, it's just y to the 4th. Now I need to make sure I rewrite it because you want to rewrite it so that all of your non-radicaled values are in the front. Anything that's inside of a radical is in the back. So in the front, I'm going to put x to the second, y to the 4th. Behind it, I'm going to put square root of x. And there's my final answer. Yeah, not during notes. Everybody clear?
Yes.
All right. I'm going to have you guys try just 2 of them on your own. Trash. All right, who can raise their hand and tell me what they got for problem number 3? Elijah?
X to the third, y to the second, b to the third, square root of y and z.
Very good. Okay, so if we split these all up, I know that x to the 6 is an even numbered exponent, so I can break it apart as just the square root of x to the 6. When I take half of the 6, it's going to give me x to the third power, and I no longer have a radical sign, so that's as simplified as that part's going to get. For the y to the 5th and z to the 7th, both of those are odd, so I'm going to break these apart. The square root of y to the 5th, I can break it apart by taking out one of the square root of y's, and then that makes the other, I'm going to go ahead and do this in pink since it's now an even. It's now y to the 4th, square root of y to the 4th. Well, square root of y to the 4th is going to become y to the 2nd, and then you still have square root of y. And then the same thing for z to the 7th. We have the square root of z to the 7th. If I break apart one of the z's as square root of z, I'm now left with 6 for my exponent, so z to the 6th power. Take half of z to the 6th, that's going to become z to the 3rd, and we're still left with the square root of z. And now we piece it all together. All of the pinks are going to come in front, so we're going to have x to the 3rd, y to the 2nd, z to the third, and then all of the green's going to go inside of a radical, y, z. Okay? That's it. That's your final answer right here. Okay? What about for problem 4? Who can tell me what they got for number 4? Lena? Very good. Square root of c, not a power of c. Square root of c. Okay? So again, a and b both have even exponents. So when I break those apart, bless you, square root of a to the fourth is just going to simplify to a to the second. Square root of b to the fourth is going to simplify to b to the second. No more with the square roots. And then square root of c to the ninth. C to the ninth is an odd exponent. Ooh, y'all need to stay away from me. All right, so we have square root of c that we're going to remove. And then square root of c to the eighth is now an even exponent that we can simplify. It becomes c to the fourth. And you still have square root of c. And now all you do is you combine all of your evens together. A to the second, b to the second, c to the fourth, and then your green stays inside the square root of c. And that's your final answer. Any questions? Jordan?
Will be numbers inside the radicals too?
Yep, that's what we're doing next. We're now going to combine our knowledge of square roots of numbers with our square roots of variables, and we're going to put them all inside of one. Okay? And then Monday we'll talk about quotients. How you have square roots with fractional values and variables. And then we'll talk about how to add and subtract with radicals, and how to multiply and divide with radicals, and then how to FOIL with radicals. FOIL. First, outer, inner, last. Yes, yes, you need to come in with a tinfoil hat. Okay.
We're going to wear dunce hats.
All right. Shh. So I'm trying to switch around how I do my notes, because I used to do quotients first, and then I went back to this and combined, but I think I'm just going to focus on combining now, and we'll do quotients on Monday. All right, so let's take a look at a couple of practice problems where we combine all the information together. So if we have a problem like the square root of 512 m to the third. It's not hard, it's not hard, guys. Stop. All you're going to do is you're going to split it up based off of, so what I'm going to do is I'm going to always do my numbers in blue for now on. And I'll always do the variables with the pink and the green. So what I'm going to do is I'm going to split this apart. I know that this is my number value, so I'm going to separate them. That's all you do. The nice, easy thing about radicals, guys, when you've got multiplication of radicals, you can separate them into their own individual radical signs. So we can separate this as square root of 512, which you know how to do. And then m to the third, am I going to highlight that in pink or green? Green. Green, because it is odd. So I'm going to highlight that in green and separate it out. This is now going to be square root of m to the third separated. And then you just work on one at a time. Let's work on the number 512. We need to figure out what is the largest perfect square that can go into 512. So the largest perfect square that can go into 512. If you need to make your list off to the side, I know that it's going to be 2 times 256 will equal 512, which right off the bat, 256 is a perfect square. What's the square root of 256? 16. Shh. 16. If I went on with my list, there's lots of perfect squares. I'd have 4 times 128. 4 is a perfect square. If I did 8 times 64, 64 is a perfect square. If I had 16 times 32, 16 is a perfect square. So if you notice, all of these, look at every single one of these. 256 is a perfect square. 4, 64, 16. All of those are perfect squares. But again, you want to focus on the largest one, which is the 256. So we're going to split this up as the square root of 256 and the square root of 2. Because the square root of 256 times the square root of 2 will give you square root of 512. So now that we've split them up, what is the square root of 256 again? 16. So we have 16, and then we still have square root of 2. Okay, you are done with the number part. Now focus on the variable. How do we work with odd variable exponents? Lena? Good. You take one of the variables out, so subtracting 1 away from your exponent, and then it leaves you with an even exponent. So we now have m to the second and m. What is the square root of m to the second? M, or m to the first, but you just have to write m. And then square root of m we can't do, so we leave it as square root of m. Okay, now, everything that is not in a radical sign goes to the front. So which component am I bringing to the front? Mateo? 16. Anything else coming to the front? And an M. 16 and the M. Those are coming to the front. What's going to go inside of the square root? 2M. That's inside. That's inside. So 2M. That's your final answer. Because you have a 2 that's inside of a square root sign, and you have an M that's inside of a square root sign. No. No. You don't see how this would be what? In a word problem, most of these won't. But you can have the word problems anytime that you're focusing on things like area of a value is, like the area of my garden, my square garden is 512. So what would the perimeter be? So like those problems that we had given before on that worksheet, well then you would have to take the square root of 512, multiply it by 4 to find the perimeter. So like how much fence do I need to put around that garden? Okay, so there's different ways, and how you're going to be utilizing this information later is when we get into our next unit on Pythagorean theorem, where you're square rooting everything, and that's making perfect right triangles that you can make a lot of word problems out of that, okay? But they're all about perfect squares and radicals.
So is m in a radical by itself irrational?
Yeah. So these would be irrational, this would be rational. Shh! Quiet. Huh? We are going to be doing the same thing as yesterday's homework, but we're now going to add numbers and variables into it. Okay? All right, I'm going to give you one to try on your own. Is there anybody absent today? Everybody's here?
Oh, you got it for 2 seconds before.
Shh.
I have the answer.
Great, just hold on, okay? All right, Elijah, what did you get?
I got 10, a to the fourth, b to the second, to square root 2a.
Very good. All right, let's take a look at it. We're first going to break apart the 200. That's square root of 200. If we focus on what the perfect squares are for 200, we have 2 times 100, which we could obviously stop there. But if we kept going, we'd have 4 times 50. We would also have 5 times 40. We would also have 10 times 20. But again, we're going to stop because that 100 is the largest perfect square that we want to focus on. So if we break this up, it would become square root of 100 and square root of 2. Square root of 100 can be simplified to just 10. Square root of 2 cannot be simplified any further. It stays square root of 2. A to the 9th, that's going to be an odd exponent. So we're going to focus on breaking it apart. So if we've got the square root of a to the 9th, that can be broken up as the square root of a to the 8th, square root of a. And square root of a to the 8th, that's now an even number. So we can simplify that as a to the 4th. And then square root of a is going to stay square root of a. B to the 4th, that is an even value already. So when we do square root of b to the 4th, just divide that in half, you get b to the 2nd, no longer having a square root. Okay, now, anything that is outside of a square root will come to the front. So we've got a 10, an a to the 4th, and a b to the 2nd. Anything that is inside of a square root will go inside. So we have a 2, and we have an a. And there's our final answer. So what you're going to do now, I'm going to go ahead and copy down some questions for you to do for an assignment. You will turn it in on Monday. Shh. You have until Monday to get it done. If you get stuck on anything, please feel free to message me and I will help you. I will give you some hints. But please, guys, make sure you show me what you have done at quiet. Make sure you show me what you've done at that point first. Don't just go, I don't know what to do, and not try. You need to still try. And then show me the work that you did to try so that I can find where you're messing up. Okay? Jordan?
Would a common misconception be that when you
Yep. So some of the mistakes that people make, like another common misconception that people have done when they have something like a to the 16th and they have to take the square root, instead of dividing it in half, they want to say a to the 4th because they wanted to take the square root of the 16. But since it's an exponent, you're actually dividing the exponent in half, okay? Once it's simplified, you don't simplify again. All right. Another issue is that once they've simplified it, they still accidentally leave it inside of a square root.
How many questions are there?
There's a lot of different mistakes that people can make. All right. Here's your assignment. I haven't decided yet. Shh. Guys, the more you ask me to just do this much or that much means the more I'm going to add on. So get quiet. Sure, I'll do 80. Let's go with that.
Yes. Georgia Moss.
What have you done?
When you try to be funny, I'll take it serious. Hush up.
Can we do the work on submission of paper?
Shh. That's 31 plus 5, yes. All right, there you go. I would like it if you work on the same sheet that you're doing. You can rewrite the problem, show your work down here, and then just put your answers right below it. So here's what I want you guys to do, so listen very closely. When you are working through the problems, work it out below and on the back and on a separate sheet, whatever you need to do, and attach it with it. as long as it's on, you know, next page, whatever, because I don't want you ripping these out of your books. I want them to stay inside. You'll exchange them afterward. Right here, and you're going to circle it, put a box, whatever you need to do. But below the problem is where you'll put your final answer. Below each of the problems, you'll put your final answer. Is that clear?
Yes.
Okay. That way it's easier for the person who is grading it. All they have to do is just go, okay, here's the problem, here's the answer. Here's the problem, here's the answer. Here's the problem, here's the answer, and so on and so forth. They're not having to look through all of your work. But you need to have your work shown, because if you don't show your work, I'm taking 25% off. Is that clear?
Yes.
All right.